Hi everyone, this is Sam Gabriel. In today's video, we're going to talk about HashiCorp's newest product called HashiCorp Boundary. But before we get into this, I'd like to ask a favor of you. Could you please write to me in the comment section of this video, letting me know what topics you'd like to watch, and I'll do my best to accommodate. So far, the videos that I've recorded are based on conversations that I have with customers and some questions that they might have. So I'd like to open this to the community and do my best to accommodate. Also, if you like these videos, please support the channel by liking them and subscribing as well. All right, so let's get started and take a look at Boundary. Okay, so let me present this these slides to you to just go over the kind of the background. So first of all, the agenda for today, we're gonna have a few slides to talk about Boundary, what it is, what it's trying to solve. Then we're gonna do a demo. So we're gonna look at you know, the product itself, run it in dev mode, and use Terraform as we're used to for configuring Boundary. So there's already a Terraform provider, and I have to say I'm quite impressed by the 0.1 release, the very first release that the HashiCorp team has released. It's full of features, very nicely done. And then we're going to take a look at how to authenticate to Boundary. Then we're going to run SSH connection to a Linux server that I have here in my home lab. We're going to run Wireshark to take a look and see what's going on with this SSH connection. Then we're going to run a remote desktop connection to a Windows server that I also have in my home lab, also running Wireshark to check this RDP connection, see what's going on. Then we're going to wrap it up with a conclusion. All right, so let's take a look at a traditional workflow and understand what we're trying to solve here with Boundary. So in a traditional workflow, if you are an operator and you have your computer at home and you want to access your corporate network, for example, or a data center. So what happens, well, you probably have a VPN that you need to use to connect. And then from there, you might have an SSH bastion host or a jump box. And then from the jump box, you SSH through a firewall to finally get to the machine you want to access. Again, that machine could be anything. It could be a server, a Linux server, Windows server. It could be a network device, a switch, a router, and so on. So what's the problem with this? Well, there are a number of things that are some issues here. So the first issue is, well, first of all, the onboarding process is not straightforward when it comes to VPN concentrators, right? So I used to be a network engineer, and you know, we used to get these requests all the time. So it's not simple to onboard, and then you have to make sure that you offboard folks after they're done. You know, third-party vendors or even you know, employees of the company itself. So yeah, onboarding is not that easy. And then the second issue that we run into is, well, you have to maintain this SSH jump box, for example, and now not only that, your user now has network access. So once they've authenticated through the VPN, they're inside your network. Now they can do pretty much a lot of things. So what happens is now we have to put a firewall in front to only allow you know, access from the jump box, and it's all based on IPs and ports. So this process is pretty brittle in a dynamic environment. If we're now talking about, you know, an environment in, let's say, a cloud, Azure, AWS, GCP, for example, in a VPC, a virtual private cloud, it becomes a lot harder to manage, you know, dynamic set of IPs. So this is pretty brittle, and again, we're depending on IPs and ports and updating this firewall, right? So another issue here. Then the last piece is that, well, the user here needs to know the credentials of the end target host that they want to access. So this is a database. You need to have a username and an access to the database, a username and password to the database. So that's also a concern from a security point of view. Okay, so now let's see what the boundary workflow looks like. So once again, the user here needs to access a host or a set of hosts. So now what happens? Well, the user now logs in with a trusted identity. Think of Okta, Ping, Active Directory, something that's outside of Boundary. So this is not necessarily Boundary. This will integrate with Boundary. So from an onboarding perspective, it's pretty easy and it's tied to a trusted identity provider. The onboarding and the offboarding is pretty simple, right? So once a user is no longer part of the company, for example, we can take them out of Okta and you're good to go. You know that they have no more access to your resources. The next step here is authorizing who gets to do what. So based on roles and logical services. So this is pretty robust in dynamic environments. And then finally, well, the third step actually is the user has a catalog now to select different applications and hosts that they have access to. And the user, most importantly, does not have access to the entire network. They're not sitting inside of your network because Boundary is brokering the connection. And then finally, they will have access to the end host, but the application credentials themselves are not exposed to the user. So dynamically, you can have either short-lived credentials that get created for the user to use to access, let's say, a database, or even credentials that are not even visible to the user. They're automatically authenticated and on the device directly without having any credentials seen at all. So that's what Boundary is trying to solve. And this is the end goal for the 0.1 release. There's a few things that haven't been integrated yet, such as Okta, for example, is not there. Dynamic secrets through Vault is not there yet, but it's definitely coming soon. Okay, so Boundary overview. We kind of covered this a little bit, but I want to focus more on how Boundary does it. So you have your users. They come in through an identity provider to authenticate, similar to what we're used to with Vault. So again, using maybe GitHub or Okta or Active Directory, even the IAMs from the cloud providers. Then you have to authorize to be able to see the list or the catalog of available hosts and services. And finally, maybe Vault is integrated here, give you dynamic access, dynamic secrets that you can use. They're short-lived to be able to access your hosts and services. And then you're able to go there and talk to the different hosts. So really, Boundary is solving the user-to-machine access problem. Okay, this is a very busy slide. I'm not going to go through the resources and description. You can do that at your own leisure. But what I want to focus on here is really the architecture and the structure of Boundary itself. So the way this is broken down, it's a hierarchical. It's a hierarchy. So you have your global piece. Then inside global, you have different organizations that you can configure. Within an organization, you have different projects. So you can see project 1, project 2. And in an organization, you have different authentication methods, and you can add users, and users can be part of different groups. And then inside of a project, you can have different roles, and the roles will have access to your different targets. And a target is really tied to what we call a host set. And a host set is made up of different hosts. So these are the actual devices that you're going to connect to. But also the host sets are part of what we call a host catalog. So in this example, we have an Azure host catalog and we have an AWS host catalog. And then within each catalog, we have two host sets. We got an app host set with different hosts. We have a database host set with all databases. So host database set 1, database host set 2, app host set 2, app host set 1. And so we have two targets here, a database target and an app target that you can configure. And then the user, maybe if you have DBAs, they would only have access to the database targets in the different host catalogs, and they can only access their databases, for example. So that's kind of like the structure of Boundary, how it's all broken up. Now, in a production deployment, this is how everything kind of works, and this is the architecture. So we have what we call controllers and workers. So the way I'll explain this is basically you have your client. This is the user that wants to access the different targets. This user is sitting on the internet somewhere, right? So I might be at home and I want to access a VPC in AWS, for example. So we have a region here, we have a virtual private cloud, and then we have different availability zones. Then we have public subnets and private subnets. Now, when you're replacing Boundary, you want to make sure that the worker nodes for Boundary are in the public subnet, and these worker nodes are basically the brokers that will allow you to connect to your target instance. Okay, so they have to be on the public subnet to be able to get access from the internet. Now the controllers, this is where the API is. This is where you would connect through an application load balancer. So the controllers sit in a private subnet, and the application load balancer is what exposes them through the public subnet to the internet. So again, they're secure in a private subnet, and the solid green arrow here, this is the client talking to the controller. So if you need to do things like add users, like all administrative tasks, add users, add roles, add groups, authentication methods, and so on, this is how you access the controller for administrators. And then for users to actually talk to the target machines and access the target machines, they have to go through the workers. So the red solid line here, this is the client talking to the target host through the worker. Again, it has to be on the private subnet to be accessible. And then from here, the worker has to have also access to the targets, obviously, to be able to make the connection. But since you're in the VPC here, you should be okay. You should allow this access. So the workers now can broker the connection to the target instance, and you can have multiple target instances, again, in different private subnets. They don't have access to the internet at all, but you do have access from outside the network. Now there are two different pieces here. The Postgres RDS here, for example, in AWS, is the database for the controllers, and also Boundary relies on a key management service as well, a KMS. So that's kind of the different components. Now there is a reference architecture for deploying Boundary in AWS, a production deployment in AWS. And I have a section on that at the very end in my references. Now, what are we going to do with the demo today? Well, I have a simple demo for you. And the way this is going to work is that I have my Windows 10 machine. This is my client machine. And it has an external IP. This is the IP that's on the LAN. And I have an internal IP as well. This is the IP because I'm using Windows Linux subsystem. That's the actual IP of the Linux VM, if you will, inside of my Windows environment. The reason why I'm putting these IPs, though, it's important because we're going to run Wireshark, and I'll show you who's talking to who's brokering the connection, and so on. Then I have a Ubuntu machine running the Boundary server, and this is running in dev mode, so both the controllers and the workers are all on the same machine. And the IP of this Boundary server is a .80. And then what we're going to do is we're going to SSH into a Linux box with a .90 IP. And then we're going to do an RDP session to a Windows 2016 server. And that one ends in a .7 IP. All right. And again, we're going to run Wireshark on my computer to kind of see how all we see on Wireshark is the connection to the Boundary server. We do not have, or we don't see any connection going to the actual end hosts themselves. That's the reason why I'm showing the Wireshark capture, just to verify that this is only done through like the brokerage is happening through the Boundary server. So the references, these are all the references that I've found very, very useful in understanding what Boundary is all about. We have a blog announcement. Arman Dadgar, the CTO and co-founder of HashiCorp, also has a very good whiteboard session that I highly encourage you to go through. There's the Terraform boundary provider, which is very, very good, and we're using it in our configuration today. There's the Getting Started Learn Guide. I went through that to understand every little piece about Boundary. There's the production AWS reference architecture I talked about earlier, and then what high availability is all about. And then finally, roadmaps. And I actually want to touch on the roadmap section really quickly because it's exciting where Boundary is headed. So if you go down to, there's the vision section you can go through, but the next steps really, as I mentioned in the beginning, Boundary is moving towards integration with different OpenID Connect, auth methods, or as I mentioned, Okta and Ping and so on, Active Directory, so that you can bring your own identity, and that will be the identity that you'll use to authenticate into Boundary. And the next piece is just-in-time access. So using something like Vault and integrating with Vault to give you the ability to get ephemeral credentials for your Boundary sessions. And then target discovery. This is neat because now you don't need to manually put in the targets that you want to access, the IPs that you want to eventually access. But through integration with something like Console, for example, or the major cloud platforms, AWS, GCP, Azure, or even through Kubernetes, there can be like a discovery mechanism, a host catalog discovery that dynamically populates the target machines, so you don't have to manually go in and add them yourself. So very exciting where this is headed, and I'm looking forward to see the new releases that come up. Okay, so let's get into the demo. All right, so what I'm going to do now is first I need to start a Boundary server. So let me copy this command. And here I'm on my .80 Linux machine that I'll have that I'll run the Boundary dev server on. So what I'm saying here is let the API listen on all IPs. Same thing for the cluster listener, the proxy, and then the worker public IP address is the .80. As you can see here, a few things happen. In dev mode, you get an admin username by default and a password by default. And then you have a host catalog ID, a host ID, host set ID, and these are the listeners that I specified earlier. Here's the worker public address, and now we're ready to go. The controller and the worker are sitting there waiting to receive commands from us. So let me move this here, because now the next step is, a couple of things I can authenticate into the Boundary server. So let me copy this, and let me expand this a little bit. It's clear here. So what I'm going to do here, let's see here. What we did is I first exported the Boundary address, the .80, because now I'm sitting on my Windows client machine, right? So what I did is I exported the address, and then the authentication method took over here, where I'm authenticating using the default authentication method that's provided for the dev server. My login name is admin, my password is password, and this is just to create the token and save it here locally on my machine. And then I export the Boundary token that I just created, and now I'm authenticated into Boundary. Now the next step is to actually run Terraform. So let's clear that again, and just run Terraform apply. And while that runs, I have a main Terraform file here that is specifying the version for the Boundary provider. Again, pin the version, always pin the version. You can see the connection here. I'm just using admin password and the authentication method as well. And then, the resources. So we have a global resource, a global scope, a corporate scope that I call it Corp1, and the password auth method. And I think it's ready. So let's say yes. Create user accounts. So I'm creating here some accounts and just looping through the different variables here. So if you go to the variables file, you can see a number of things. You can see some users that can pre-populate with, some read-only users, some of the backend server IPs. So you can see here populated with some. You can put IP addresses. You can also put host names as well, or fully qualified domain names. And here's my Windows server also. So all that gets taken care of through Terraform, adding the users, the read-only users, and the accounts, and then the users themselves, then the group, the read-only group. Then we're adding some roles, and in the roles we can add some grants. What are they allowed to do? In this case, the read-only group is only allowed to read. The admin group is allowed to create, read, update, and delete. Boundary scope, host catalog. Here's the catalog that we talked about, and within a catalog, you would have the different host sets, and then within the host set is the different hosts. So here we're defining the different hosts, backend servers, backend Windows server. Then here's the host set that again encompasses the different hosts, and then we can create the target. So I have two targets here. This is target for port 22, and as you can see, it's for the backend SSH servers, backend servers. So, and it's talking to the host set IDs, or it's calling on the host set IDs. So a target always talks to a host set IDs. And then the other one is for RDP port 3389, right? So you define the port here, and then the host set ID defined here. Now, one thing to note, you need for RDP, you need at least 2 session connection limit, right? If you put -1, it will allow you as many as you want, right? It's unlimited. But yeah, I learned this the hard way. I have to go through some errors to figure this out. For SSH, you're fine to allow, you don't have to even have to specify it here. By default, the session connection limit is 1, but I had to move this to 2 to be able to get RDP to work. So that's it. Really 2 files here for Terraform, a variables file and a main Terraform file. And everything is now ready to go. So let's move to the next step. And this step is where we're going to run SSH and RDP to the machines and see how this all works through Wireshark. Okay, so to do that, I need to use this boundary connect command, SSH, and I need 2 things. I need the target ID and I need the host ID. Now these were, I put them here from a previous run, so I have to go into, let's rerun this. I have to go into boundary and capture that. Now this was a previous run, so I'm just gonna re-authenticate in here and show you what the UI looks like. Let's see here. Okay, so let's delete this so we're at the root. Now this runs at port 9200. I guess similar to Vault, which was 8200. Now we're at 9200. Okay, admin and password is the default here. And then you see a couple of things here. At the global scope, you have organizations. So you have a generated org scope that's automatically generated when you run in dev mode. And then Corp1, this is what we generated through Terraform. And in here, you have a few things. Remember the structure that I showed earlier? So I have users, groups, roles, auth methods, and then projects. So first the users. These are all the users that we've populated. And then you can create groups like the read-only group that we showed. And then you have the members of the read-only group. Then you get roles. So as we saw earlier, we have an administrator role. Administrator and login default grants are actually auto-generated with the dev mode. Admin and read-only is what we did with Terraform. So here you can see the principals, the name of the users. The different grants, so as we saw earlier, create, read, update, delete for admins. And then for the read-only role, the principal in this case is a group. So it could be a group, it could be a user. And in here, the grant is only, the action allowed is only to read. The auth methods is the only auth method allowed here, which is a password. Again, this will, we'll have more authentication methods through Okta, through Active Directory, and so on in future releases, I'm sure. And here you can see the different accounts that are created here based on this auth method. So that's outside the project. Now, if you go inside the project itself, click on the core infrastructure project. Now we have a few things here. We have sessions. So no sessions are running at the moment. Once we SSH, we can come back and take a look at a session that's running. And I'm pretty sure we're probably going to see some sort of session recording at some point. It's not available today. Targets. So here are the targets that we're targeting. So we have the SSH backend servers, and you can see the maximum connections here is 1. The default port is 22, and then the host set is the backend server SSH host set. And then the other target is the RDP target. And in here, you have, again, the maximum connection is 2 for RDP, the default port for RDP, and the host set is the Windows server that I have here. So let's go and grab the target IDs. So this is for RDP. So let me go back here and put it in my notes. So for RDP, let's put this one here. And then for the SSH servers, let's go back here and put the target here. And now let's go into the host catalogs. And remember, within the host catalog, we have the host sets. So here's my host set, 2 of them, the Windows servers and the backend server. And if you go in here, you can see the hosts that are within each one of those host sets. So for me, I want to do this one, the master one, which is the .90 that we saw in the diagram. So this one is going to be for SSH. So let's populate the host ID. And if we go back here, I can actually go directly to hosts and grab the one I have. This gives you every host. It's not part of a specific host set. So here's the Windows server that I was looking for, and this is the host ID. So let's go back here and put it over here. Okay. All right. So we're ready to go now. We have all the information that we need. Now it's time to connect. So let me copy this. Let's go to Wireshark. Let's create a new capture. Okay, and I have a filter here for the .80, which is the broker IP, the boundary IP server. And let's see what's going on here. So yeah, so the authenticity of this host, so we have to add this. So you just need to click yes, but before we do that, you see how it's identifying it as the local host here. This is interesting because it's going through boundary. So we click yes, and we're dropped right into the master one IP address here. If I do it ifconfig, I can probably see it here somewhere. Let's make it bigger. Just looking for the IP address to verify. So it's the .90. And now I can do one thing here. I can go back, take a look at my sessions, and you can see a session running right now, right? I can close the session from the UI here, or I can simply, let's say I'm done working here on this machine, I can exit and the session is closed. So let's go here and stop the capture in Wireshark and take a look at what's going on here. All right, so the first thing to note is the actual IP addresses that are being used. So the 154.181, if you remember, this is the IP address, the internal IP address of my Windows machine. And then the .80, if you remember, that's the boundary server. And then the SSH is going to the .90, the Linux server. Now you'll notice that there's nothing in the capture for the .90. It's only between the local Windows machine and the Boundary server. So if let's go back and just verify that. So here's the three-way handshake. You got the SYN, the SYNAC, the ACK, and it's again between the Windows machine and the Boundary server, and the Boundary server is responding, and then the connection is established. HTTP here, this is the post, this is the API call to the controller from the Windows machine. You can see it's a post, and of course in a production environment you won't run HTTP, you would run HTTPS, so this will be all encrypted. But it's actually nice to see it here in Wireshark to show you the content. So you see the authorization bearer, you can see the token that's being used here, and if we minimize this, you can see the JSON. So it's a layer 7 communication here. You can see the host ID itself is shown here, which is very interesting. And then the server responds back with a 200 OK. So we've established connection, we've authenticated. Now the next session here is another three-way handshake, a SYN, SYNAC, and an ACK from the Windows machine, once again to the Boundary server. And you notice here it's to port 9202. 9202 is the worker port. So if we go back here and notice here at the bottom, that's the worker public IP address and port 9202. And actually, while we're here, you can see the connections right here, right? So the client IP address is the 1.141. That's my LAN IP address, like I mentioned earlier. So the Boundary server is actually, it's just seeing the interface IP, obviously not the VM IP inside of my Windows machine. And here's the client TCP port. Here's the IP of the end host, the Linux server, and it's on port 22. Now, if we continue to look here, you can see the SYNAC, and then as we move down, you can start to see the SSH sessions. So SSH here, as you can see. So that's where SSH is taking over. And if I scroll just to the bottom, you can see a bunch of resets, and then the FINAC, and so on when the connection is closing. But all this to show you, really, the key thing here is if I go to the .90, there is nothing in the filter here because the broker or the Boundary server is brokering the connection. You don't see the end host. All right, it'd be interesting maybe at some point to do a TCP dump on the end host itself and show you that only the broker is talking to it. But you get the picture that there's no communication between direct communication between your Windows machine and the Linux server. Okay, so we're going to do the same thing here, but this time we're going to run an RDP connection, so a remote desktop into my Windows server. And once again, I'll show you how this all works in Wireshark. So let's go ahead and start a new capture. And let's get in here, grab the connection that we just created. Okay, let's run that. And when you run that, automatically the local RDP application runs. Right? So it's very neat. So I'm just going to log in. Okay, verify the certificate. I'm using a self-signed certificate. And I'm dropped right into my Windows 2016 server. And you can see here it's seeing it as a local host. But yeah, I'm on the server right now. If I go back, if I minimize this and go back to show you the actual connection, you can see that the SSH connection is terminated. The RDP connection is active. Right, so we can go back to my RDP session here and close that. And the session. And let's go back to Wireshark, stop the capture. And once again, you can see how the Windows machine, again, is talking to the broker. Same thing as before, HTTP post happens, okay. And then the SYNAC for the actual RDP session takes over. Once again, 9202. And yeah, I'm not too familiar with how RDP works. I always see this reset come in. So I'm not sure why. And there's a FINAC as well. And then the communication continues. You can see application data and so on. But as we saw, I mean, everything is working. And the reason why, again, I'm showing this is that there is no communication with the end machine, with the Windows server. So if I filter only on the .7, nothing shows up at all. The capture is absolutely empty. And that just shows you how, once again, there is no connection, no direct connection between the Windows machine and the Windows 10 machine and the Windows Server 2016 machine. It's all going through Boundary. So yeah, hopefully this has been helpful to show you overall how Boundary works, and see how you can utilize this in an environment like in a real environment like this, where now in your organization, instead of, like I said before, using a VPN and all the hassle that comes with that, securing in a dynamic, perhaps a cloud environment or even on-prem, securing the connections into your organization through the use of HashiCorp Boundary. Again, really excited to see where this project or this product is headed, and to see the future releases and what the team is going to release next. Thanks again for watching, and I'll catch you in the next video.